Hi guys, welcome back to my channel. In this tutorial we are going to look at this integral from 0 to 1 of the square root of x to the 8 minus x to the 6 plus x to the 4 times the square root of 1 plus x squared dx. This is an MIT integration B question of regular session 2024. So let's solve this integral. So let's start off by really multiplying the terms out in the square roots. So we have the square root of x to the 8th minus x to the 6th plus x to the 4th times the square root of 1 plus x squared. This is multiplication. So in this case, we have the square root of multiplying the terms out. You have x to the 8 minus x to the 6 plus x to the 4th plus x to the 10th minus x to the 8th plus x to the 6th, like this. And this one really simplifies to x to the 8 will cancel x to the 8, x to the 6 will cancel x to the 6, and we are left with x to the 4th plus x to the 10th, like this. So this one it simplifies to really x to the 4th, 1 plus x to the 6, like this. And this one becomes the square root of x to the 4th times the square root of 1 plus x to the 6, like this. And this is x squared times the square root of 1 plus x to the 6. So our integral, the integral from 0 to 1 of the square root of x to the 8 minus x to the 6 plus x to the 4th times the square root of 1 plus x squared dx. This can be simplified into the integral from 0 to 1 of the square root of 1 plus x to the 6 times x squared dx, like this. All right, cool. So this one becomes the integral from 0 to 1 of the square root. The x to the 6, I can write it as x to the third power all raised to the power 2 times x squared dx. And I will divide the integral by 3 and multiply by 3. 1 plus x to the third squared times 3x squared dx, like this. Right, so now let's do a u sub. So we can let u to be equal to x to the third power, like this. So the limits will stay the same. The limits when x is equal to 0, u will be 0. When x is equal to 1, u will be 1. The limits will stay the same. So what about dx? Du is going to be 3x squared dx. So it means in place of 3x squared dx, I can replace that with du. But the limits will stay the same. This is 1/3, the integral from 0 to 1 of the square root of 1 plus, this is now u squared because x to the third is u, 3x squared dx is the u. And with this, we can do another u sub. We can let u here to be equal to tan of theta, right? So the u is going to be secant squared theta d theta, like this. What about our limits? When u is equals to 0, we are going to have the tan inverse of 0 to be equal to the lower limit of theta, which is going to be 0. When u is equals to 1, we are going to have theta to be equal to the tan inverse of 1, which is pi over 4. So we can take our integral from the u world into the theta world. So that becomes 1/3 the integral from 0 to pi over 4 of the square root of 1 plus u is tan theta, so this is tan squared theta times du. Du is secant squared theta d theta. And this one becomes 1/3 the integral from 0 to pi over 4 of, this is secant theta, because this one is secant squared theta and the square root is secant theta times secant squared theta d theta. And in the end, our integral reduces to 1/3 the integral of integral from 0 to pi over 4 of secant to the third power of theta d theta, like this. And this one really is, we have done this before. The integral of secant to the third power of theta, the value to this integral is 1/2 tan theta secant theta plus 1/2 natural logarithm of tan theta plus secant theta, like this. and we are integrating that from 0 to pi over 4. This is the value of our secant to the third power of theta. So this is 1/3. So in the end, this is 1 sieve times tan theta secant theta, like this, plus another 1 sieve natural logarithm of tan of theta plus secant of theta. From 0 to pi over 4. So let's plug in our pi over 4 and 0. So this is tan theta, and theta is pi over 4 for the upper limit. So 1 over 6 tan of pi over 4, that is tan 45, secant pi over 4, minus, if you plug in 0, tan of 0 is 0, secant of 0 is 1. So that will be, so secant is 1 over cosine. Cosine of 0 is 1, so 1 over 1 is 1, but tan of 0 is 0, so that will make it 0 for the lower limit. And for the upper limit, for the second integral, that will be natural logarithm of tan of theta, and theta is pi over 4 minus plus secant of pi over 4, like this, minus the 1 over 6 times the natural logarithm. Tan of 0 is 0, secant of 0 is 1, so natural logarithm of 1 is 0, so lower limit is again 0 for the second one. So this is 1 over 6 tan 45, tan pi over 4 is 1, secant of pi over 4, that is 1 over cosine of pi over 4, that is 1 over 1 over root 2, which is root 2, plus 1 over 6 natural logarithm of this is 1 plus secant of pi over 4 is root 2, like this. So 1/6 is a constant. You have 1 over 6, then the square root of 2 plus the natural logarithm of 1 plus the square root of 2, like this. So this is the value of our integral. So therefore our integral from 0 to 1 of the square root of x to the 8 minus x to the 6 plus x to the 4th times the square root of 1 plus x squared dx. This one is evaluating to 1 over 6 times the square root of 2 plus the natural logarithm of 1 plus the square root of 2. Yeah, so this is the value of our integral. I think this one is very long, considering that we are giving only 2 minutes for the regular session. So if you find this helpful, make sure you subscribe to my channel by hitting the subscribe button. Thank you so much for watching this video, and I will catch you up in the next one. Bye bye.